was Tuesday.
Okay.
And that's why.
So we did 1 and 2 already, right?
I know.
Or did we just do 1 yesterday?
We did.
What? Actually, I don't think we got to
We
this.
didn't do
I
any.
will write her a note.
We didn't do any of these?
But you can
That
tell
is
her, you
problem.
could be the
Was it the
adult.
previous pages where I left off?
Yeah.
Well, we were about to get to those.
Okay.
Okay.
These are the ones where I
Yeah,
left off.
that's where you,
Okay.
where I got
Oh,
mad
yeah.
because you told me I was wrong. Bro.
Right, so we did both of these though, right?
Yeah.
Okay. So, oh, it was the adding and subtracting is where we left off. Okay. So you wrote down those adding and subtracting. So performing the addition or subtraction and write the result in standard form. Okay.
One of these-
So did we finish number 1 or did we leave
Yes,
off?
8 plus 4i, right?
8 plus 4i. Good. All right, so we didn't start this one then at all.
No.
All right, so what would I do? So I'm subtracting 2 complex numbers. Well, what did our formula say? We're going to subtract our real numbers, right?
But shouldn't you make the root negative 18 with like the i's?
The I thing.
The I.
Yeah, but you're going to do the reals first and then do these second, right? I mean, you could do it first. It doesn't really matter. Would you rather change that first?
Whatever. You already
What
have
is
circled.
what's it
so
going to be?
Root 18i.
Okay.
I don't know. What else
Yes,
can it be?
it's radical 9, radical 2, radical negative 1, 3,
Root 2i.
radical 2, I.
Yes. Yes.
Okay.
That.
If you want to do that first, you can. 3 plus 3, and then radical
Oh, those are
2.
going to cancel. aren't they?
All right. So 7 minus 3, right? 4. And then we have 3 radical 2i minus 3 radical 2i
4.
is 0. So 4 would be our answer.
That makes sense.
Okay. All right. So this next one, you have 22c plus negative 5 plus 8i plus 10. So,
What's the c? Is that just a variable?
yeah. So what are we going to do with what are we going to do with this one then? What's that?
Just add the i's.
Okay, what are you going to get?
22c minus 5 plus 18.
20. So you're going to subtract these?
No, 22c.
Right, you're just leaving that, right?
Yeah, I'm just leaving it.
Okay. You said
Minus.
minus. So it's, well, I'm not sure where you're minus. Your plus is adding.
I just distribute the plus in, which, you know, it's going to be minus 5.
You're adding this though. You're not multiplying it.
What do you mean?
But either
You're
way,
adding.
isn't
You're,
it still
this is
minus
commutative, so
5?
you're adding those two there.
Yeah, but either way, it's going to end up as minus 5.
Okay.
I'll
I'm
find
just trying not to skip steps.
Plus in the parentheses, minus 5
Oh.
plus 18.
Okay. So the idea is that there is commutative, right? So the complex numbers are commutative,
And that will be minus.
and that's all the example one to show you.
We're not recording anymore?
I'm recording.
Oh, wow.
The additive. Do you go on and watch? Do you guys watch any of these videos? Have you watched any?
I was
Yeah,
actually
have you
going
watched
to.
any?
I wanted to last night.
No, neither of you have. Okay.
What if I do? I'll do it tonight.
If they're helpful, I mean, but yeah, I think they would be, especially if you get to a point in the homework where one of the questions relates to one of the examples. Because I think I put an example from pretty much every section. So if you don't know a section, then if you watch the, you don't have to watch the whole 18 minutes or whatever. You can just watch the 2 or 3 minutes of the one you're stuck on, if there's only one. The additive identity of in the complex number system is 0, just like the real number system. Okay. Furthermore, the additive inverse of the complex number a plus bi is the opposite of a plus bi, or minus a minus bi. So multiply and write the result in standard form. Okay. So how are we going to multiply the square root of negative 5 and the square root of negative 10?
Positive negative 50. The square root positive 50. Maybe. Probably not.
It wouldn't be root 5I times.
Square root of negative 50,
Oh.
right?
Why? Negative. They're
When you
both negative.
when you multiply square roots, right?
Yeah, but they're both negative. Wouldn't that make it positive?
Yes.
Wait, I'm right?
Yeah. I'm losing it. Okay, so you have positive 50,
I was right.
which is what?
25, root 25 times root 2, which is 5 root 2. You said not to skip any steps.
Okay. That makes sense? What do we have for the middle one? Multiplying two complex numbers. Good. So when you FOIL it, what are you going to get? 12.
-12I.
6 times 3.
Oh, yeah, minus 18. Minus, or plus 6I.
You're doing
Or,
these two
sorry,
here.
plus 4I.
Minus, right? Minus not plus.
Whatever.
Minus 4i.
Bless you. Bless you.
Excuse me. Thank you. I'm sorry. And then plus what?
6.
6 what?
I squared, which is negative 6.
Right.
Which will be
Now you just
6
have.
minus 22I.
Good.
See?
That's not too bad though, right?
See, this is actually bad.
That's not too bad.
This makes sense.
What are we going to do with this one?
So,
Negative 18I.
Okay. So you're going to distribute it in the whole thing. So minus 18i.
plus 3I squared. Minus 3.
I squared is negative 1, right? Minus 3. And so they want it in standard form. How's the
So
standard form?
minus 3 minus 18.
Okay. Good. So adding, subtracting, and multiplying works pretty well, right? You know how to do that pretty good. Pairs of complex numbers with the forms a plus bi and a minus bi are called complex conjugates. Okay? And the reason we're going to do the complex conjugates is so that we can rationalize denominators. We don't want these imaginary numbers and these radicals in our denominator. So the first three are just practicing. So what's the complex conjugate of 7 minus 5i? It's not a trick question. So if these are complex conjugates of each other, so it's in this form, you just want to put it into this form. I'm sorry,
Or 7
plus what?
5I.
That's all, okay. That's all we did is change the minus to a plus. That's
Oh.
a conjugate, okay?
I can do that.
Okay. And so let's start with why do we want to do that? Why do you want to find the conjugate? Well, because if you multiply these together, what are you going to get? FOIL this real quick, and what do you get? 49 plus 35i minus 35i minus 25i squared plus 25. So the reason we do the conjugate, these i's drop out, and you're going to have 49 plus 25, which is 74.
Which is something. It's a number.
Okay?
It's actual math.
It's
Do
actual.
you see that?
Yeah.
That's why they want the idea of this conjugate, is so that you can get rid of the i's.
So we can get actual numbers for once.
That's what they want. Well, everything moves into the variable, so it's still going to
No.
go back.
So we're
Okay.
gonna have like a 5ix.
All right. What would be the complex conjugate of this one?
Minus 3 minus the root 2.
All right. multiply these two together and tell me what you get.
These two grade both.
You guys do those on paper, then let me know when you're done.
Here's what you used to do.
So what you got?
Yeah.
Is that what you got, Kelly?
Yeah.
Okay, good. What's the conjugate of square root of negative 13?
Minus the square root of negative 13.
Okay, good.
Okay, so there you go.
Multiply those and tell me what you get. Multiply those together.
Well, I think the opposite of what you did.
Negative 13.
Negative 13.
You're so quick.
Do you get that, Kelly?
Yeah.
All right, just want to make sure. I don't want to go ahead and. Okay. All right. Write the quotient in standard form. So we're just dividing these now. So do this first one on paper and tell me what you get.
Is it like, or is it just like positive 5 over?
Well, you're not. So to get out here, what would be the conjugate of 2i? But you got to multiply it by itself, right? That's 1, right? So now you can multiply across.
5. Yeah, 4.
It's negative, right? This is a plus and this is a minus, right?
Well, how do you get
Oh,
Yeah.
all right. I was going to do the I squared, so you just skipped a step ahead. That's fine. So it'll be the opposite, which is plus. I was doing 4i squared, which you already did the I squared, made it a negative 1. So, right?
Let's go with that.
Is that what you had?
Yeah.
This times this is 4 minus 4i squared,
Okay.
and this is just negative 1, so it's just 4, positive 4.
And how is the top at positive 10i? Is that because the 5 is negative?
Yeah, this was a negative up here. This goes with the numerator, right?
Yeah, sure. But
Right? Well, if you have negative 3 halves, that's just negative 3 over 2, right?
But it could be negative. It could be positive.
You could have put them in either way. It gives you the same answer because you're going to pull it out at the end.
Are you sure?
But like I tell my Algebra 1 students, you want to put them with the numerator. It's usually what we do,
Would
right?
it be a negative 4 in the end, though, if we did it negative 2i times negative 2?
Well, when we do it like this, we're just going to pull it over and say negative. It's just negative 10i over 4. So whether you have the numerator, it's going to go back out in front. So it doesn't really matter, right?
Yeah. Okay.
So the only difference is does that make sense?
Yeah.
What's the conjugate of 1 minus I? 1 plus I. So you got to do the numerator and the denominator.
Central distributing.
They're just foiling on the bottom, right?
3 halves plus 3i over 2. Am I right or no? Oh,
Is that what you had?
I had 3i over 2, but it doesn't make a difference. 3
This is
halves.
just 2, right? So
3
3 halves here.
I have 3 halves plus 3i over 2. That's the same thing.
Yeah.
Yeah. Okay.
Okay. So you can add, subtract, multiply, and divide complex numbers. So there'll be a bunch of those in the homework. So The next part is the complex plane. And of course, when you're doing, as you can imagine, you're going to get more difficult numbers. So they'll put exponents, and then they'll start putting radicals. All kinds of things will be in there. So, but it's no different than adding 3 plus 3. You're just adding larger numbers. If they give you fractions, it's the same thing. When you have a quotient, you want to make sure that you multiply the same thing by the top and the bottom so that you can get rid of that I in the bottom, so you can rationalize it. That's what we call it, okay? So now what we have is this idea of the complex plane, where we graph our complex numbers. So you can't graph complex numbers on the real plane because there's imaginary numbers, the imaginary part. So instead we use this idea of the complex plane. And so you graph the real number on the real axis, which is the horizontal x-axis. And then you're going to graph the imaginary part on the vertical axis, the y-axis, the imaginary axis. So pick a complex number for me, Ben. It doesn't matter which one, just pick
How
one.
about 2 plus 2i?
All right. So we go. So up here is the point 2 plus 2i. Okay? Make sense?
Yeah.
All right. Now, I'm not going to spend a lot of time on this thing called the Mandelbrot set, but I want you to know what this is all about.
What is
And
it?
there's some cool pictures. Your book actually doesn't have very cool pictures, but if you go online, and actually I think on your website, on your wiki space, you have a video of the Mandelbrot set. There's some really cool pictures. That's well worth 10 minutes of your time. I think it's a 10-minute video. To go do that tonight. Do you guys go on the wiki space a lot? I mean, I know you watch videos, but okay. But you know how to get there, right? There's no question about that. So if you would do that for me, go on tonight and just watch that for 10 minutes, and I will spend 20 minutes going over the Mandelbrot set. But I'm going to tell you what it is, and there'll be some really cool pictures. Okay? So what they do is, they discovered a while ago that depending on how you graph these, what kind of series, and you guys did series in Algebra 2, you know, n plus 1, n plus 2, all that kind of stuff. You could make any series you want. And as you put the complex numbers in and substitute them in, and you plot the points, it turns into different shapes. So one of the most famous ones of these is called the Mandelbrot set. And this sequence is any complex number. That's what the C stands for, complex number. It's a variable, but that's the variable is a complex number is what we use. And what they do is they square the previous item in the set and then add the same complex number on. Okay? So if I was using 2 plus 2i, it would be
4 plus
2 plus 2i. That would be the first in the series. And then the second one would be 2 plus 2i squared plus 2 plus 2i. So they just square it and then add the complex number on. That would be the second set. They took this, whatever this one was before, they squared it and then added the complex number on again.
Yeah.
That's simple enough. Okay. So what would the third set have been?
2 plus 2.
2. Sorry, I'm in
I don't know.
the. Yeah, no, you're doing all right. I was just in the way of the thing. 2 plus 2i squared plus 2 plus 2i. So that was the previous step, right? And then they just squared that. And then added on 2 plus 2i. And that was the third step. And then so on and so forth. And so it would just keep getting bigger and bigger and bigger. And what happens is, again, your book doesn't have a great picture, but there are some pictures in there. If you go to page 132, it gives you some. And there are some pictures. I have one at home. I have a poster. Maybe I'll bring it in. I have a poster of the whole thing. Well, not the whole thing, but like the first 16 in the sequence. But it makes these cool spirally pictures. And the video, actually, that's online, that she has online, shows it as well. And so you just get these cool, like, little spiral things. And that's what the Mandelbrot set is. Okay? Now, in your homework, I don't think I assigned it, but if you look at the questions, I think it was number 73. It's just said use those numbers for your complex numbers, like negative I,
Huh.
and just substitute those in and then plot them. So you could do that and plot all those and make a neat little shape. You don't have to. That'll take you some time.
You put
I
74.
did put 74.
But you know what?
Oh, I used 2 because 2 is an easy one to do. There's no imaginary number there. 2 is.
I'll have fun with it.
So, and I think it only says to do the first 6 terms. So, 2, then what?
2 squared plus 2.
Well, 2 squared plus 2, then 2 squared plus 2 squared plus 2. Those are the first 3. So then they went 6. So that was all.
Oh,
There's not much to that.
okay.
But it makes these cool pictures. They really are. They really are. I'm telling you, watch the video. Just watch the video for me. Take 10 minutes. It's really cool. And then I won't have to spend an hour on the homework. And so they just want you to know what this Mandelbrot set is. Okay? And that's all they're getting at.